Happy Tuesday. I am here to do our compound inequalities notes. And compound inequalities are just like a compound word. It's actually where you have two separate inequalities, but you want to solve them you will solve them separately. However, you will graph them on the same number line. So we're going to do a few examples together, but I want to let you guys know sometimes you will be separated with the word and, which is what we call a conjunction. We want to put things, we want to find out where they share a common answer, and that would be in between the two values that you solve for. And then the second part is a disjunction, and that's separate. The inequalities will be separated by the word or. And on those types of problems, you will see two numbers as part of your solution, and then they will be shaded outside. So you either want to be below this number or above this number, but not necessarily in between the values. So I'm going to start with some examples of conjunctions, and then we'll do some disjunctions. Sorry about the quality. I'm trying to get this marker off, or the marker off the cap. All right, so our first example, you might see something like this. 2x plus 1 is greater than, let's go with 3, and 3x is less than or equal to 15. So we can have two inequalities. So you solve them separately. So you would solve this one just like we would on the previous lesson. Subtract 1 from both sides, and we get 2. We divide by 2. We do not have to flip our sign, so we get x is greater than 1. So x is greater than 1. We will graph this in just a little bit, but right now I'm going to go and solve this one. So this one, all I have to do is divide by 3, and I get x is less than or equal to 5. So we are going to graph both of these solutions on the same number line. So the two numbers in the solutions are 1 and 5, so I want to make sure those are on my number line. 0, 1, 2, 3, 4, 5, and 6. Okay, so we have both of those. All right, at 1, it actually tells us that we want an open circle at 1 because it's not included, not equal to. It's just greater than 1. Now, greater than goes to the right. Now, I'm not going to shade completely yet. I'm going to show you guys something. In a conjunction, we want to find out the area where both of these solutions share the same numbers. So then if you want to graph x is less than or equal to 5, net or equal to means it's a closed circle at positive 5. Now, less than means go to the left, so shading to the left. So if you see, this area in between the values is where they share, where they come together, and that's actually what conjunction means, to put things together. So if you see something like C-O-N in a word, it actually means with. So the solutions that they share with each other would be the numbers in between 1 and 5. And so we would shade this area of the graph. So whenever it is a conjunction, when you see the word and, you should be shading in between the two values. Now we're going to do another type of example like a conjunction, but it's just written a little differently. So if you are not ready to move on yet, just go ahead and hit pause and then hit play when you're ready to start the next part. All right, conjunctions can also be written like this. Let's pick a good number. All right, so sometimes you see conjunctions written where both inequalities are written together. So the 4x plus 10 goes to the negative 2. It's also part of this less than 38. Now, you can solve this at the same time. So normally, whatever we do to one side, we have to do the other side. But since we have two inequality symbols here, I'm going to put those up as like a little boundary line. The only thing we want left in the middle is the x. So we can say what numbers it's in between. So for just a second, I want you to ignore the -2. So I'm going to actually just move this. If this was just by itself, what you would do to solve this is subtract 10. You would subtract 10 from here, and you would subtract 10 from here, which is great. That is the first step. However, you have a left-hand number that you also need to work with. So if you pretend like you're solving that by itself, whatever you do here, you also have to do to this third number that's over here. So we have to subtract 10 from all three parts. So this becomes a -12, which is less than or equal to 4x, because those 10 minus 10 became 0. And then on the other side, we have less than 28. All right, so same thing. I always just like to ignore the left side for just a second. If this 4x is less than 28 stood alone, we would divide both sides by 4. So if you do that here, you also have to do it over here. And then we just simplify. -12 divided by 4 is -3, which is less than or equal to x, which is less than 28 divided by 4 gives us 7. So it gives us two numbers and two inequality symbols to know what circles to make on our number line. So at this point, now I'm going to be a little shorthand. I'm just going to put the two numbers that I have here on my number line. I understand I should probably put more numbers on my number line, but I just want to show you guys. This symbol that is attached to -3 is the one we work with. So if you look at this, just this part, -3 is less than or equal to x. That would actually be a closed circle. Now, this time, you have to ask yourself, we've been solving where we put the variable on the left. This time the variable is on the right, so we want to read that backwards. X is greater than or equal to -3, because we see the greater than symbol points towards x. So x is greater than or equal to -3, so we're actually talking about this direction, going to the right. Now, if you read this, just the second half, x is less than 7, that would be an open circle at 7, and this time x is less than, so we would go to the left. And you can see there is an overlap where the solutions share the same numbers, which would be in between -3 and 7. You want to say, anytime you see something written all together, that is automatically a conjunction whenever it's put together. And your shading should be in the middle, but you always want to make sure that your signs correspond with that, because sometimes, like if you have to divide by a negative number, you would have to flip your inequality sign. So you always want to make sure that your signs correspond with the direction of your graph. Now, I'm going to give you guys an example of a disjunction, and then if you need more examples, feel free to look at the class notes. And if you have questions, don't hesitate to email me or call me. Hang on just a second and I'll get that erased so we can get started on the next one. So virtual kids, I hope that I'm not going too fast. And if you can't hear me, or if you think I'm going too fast, don't hesitate to send me an email and say, hey, I'm not, like, you're not doing this. All right, so we got our first half, -3 times x plus 1 is greater than 12. Or, on this side, 4x plus 2 is greater than or equal to, let's go with 6. All right, so whenever you see these, it's just like the conjunctions. If they're listed separately, solve them separately. So we're going to jump over here and we're going to solve this part first. So we got -3x, distribute here, so that becomes a -3 is greater than 12. Then we can add 3 to both sides. And we get -3x is greater than 15. Now on this one, we're dividing by a negative. Dividing by -3, and we learned earlier in the week, if you divide by a negative, you have to flip your inequality to keep it true. So we get x is less than 5. Now, we'll put it on a number line in just a second. Let's jump over and solve the other side. So we subtract 2, and we get 4x is greater than or equal to 4, and we get x is greater than or equal to 1 when we divide. I probably should have showed that division step. I apologize. So if you have two inequalities, now we have two numbers, and so this one corresponds with the circle at -5. This symbol corresponds with the circle at -1 or at +1. So we got -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. All right, so I've made my number line. And at -5, let's just look there. It should be an open circle because it's just a less than. And then the direction for less than, let numbers less than -5 go to the left. So we're going to shade this part of our graph. So that's our first half. Now, on the other side, it's x is greater than 1. So we would go to +1, put a closed circle, and it's greater than. So we shade to the right. So whenever you have a disjunction, you don't have any shading that touches or overlaps with each other. So on this, what this is telling us that if I wanted to pick any number on this number line and plug them back into the originals for x, since this shading came from this inequality, if I picked a number over here, it would give me a true statement if I plugged it in here, but it would give me a false statement if I plugged it in here. Now, also, like on the other side, any number that in this shaded area would work for this inequality, but not that one. And then you have this area in the middle that you don't shade at all because it doesn't work for either one. So like if I picked the value 0 to plug back in to check my solutions, I would get false statements on both of those because if I'm not shading it, it's not a solution. I'm only shading things that are a solution to these inequalities. So it's either less than -5 or greater than -1, but the numbers in between those don't work. So this is our lesson for conjunctions, and again, there's more examples on those class notes. Just click those on the link on the homepage. Have a great day.